Hi, good morning. I want to introduce today the lab, which is called the numerical analysis. And just let me go to the page where I have my instructions here. Of course, you're going to see this is lab 5. And you have this one is the instructions. This one you need to download this one because this is the template that you are going to use for today's work. This lab, it is just only the Excel sheet that you are going to submit. Don't make it a PDF, okay? Because this should be like a file in Excel so that I will be able to check it. This is where you are going to get your submission, and it's just as I told you, one file that is going to be an Excel. And what's the meaning of a numerical analysis? We are going to find that there are many problems that we encounter in physics and engineering. They don't have that easy analytic solution. And we need maybe to do something called numerical solutions. And the numerical solution, they were existing for a long time, but we did not have the equipment to handle, because sometimes these calculations, they're going to be very tedious. Now, of course, with having Excel, we are going to be able to do that easily. And I will say we are going to do today examples on 3 tasks. One of them is the integration. The other one is root search. We're going to find the root for an equation. And another one is getting rid of a noise from a signal, which is sinusoidal noise. Now, when you download this, okay, this file here, I have downloaded that, and I'm gonna just look at it and see. This is not the one. Oh, sorry. Where is my file? No, okay, this is my data. Okay, it seems, yeah, this is the one. Okay, then this is when you download the file, you are going to find root search, empty nothing, integration, and sine noise. Okay, now the first one I will go for, it is like in the order what we have in the sheet, and that one is gonna be the integration. Now some integrals are easy to solve, others they require different techniques. One of the techniques, remember, we said it is the area under the curve. And this function is really maybe in numerical integration is going to be very preferable in this one, which is e to the x sine x squared. And what we will do is here, we are going to start from B4, and we are going to enter 1. And then I'm going to enter the next one. It is 1.01. Let me have this like the font bigger. I mean the zoom. Okay, why it's not working? Okay, 1.1 and then 1.02, and then I will highlight these, and then I'm gonna end up, okay, I want to have my numbers up till to 5. Then I'm gonna have like, just very little triangles. I'm gonna find their area, and I will, add all these, areas, and this is gonna be my integration. Okay, then here I am approaching. Okay, one more. Okay, then here I have entered my numbers from 1 to 5 as in increments of 0.01. Now the next column is going to be you enter the function, and then you're going to say, whenever you are going to enter the function, you're going to say equal, and then here I'm looking the first function, I'm looking, it is exp exponential. Okay, then here I'm going to insert this function. okay, the argument of this function is x, which is b4, and then times, and then I'm gonna search also for another function which is sine, and then I'm gonna insert the sine function, and inside the sine function I'm gonna have again b4 but to the power 2, and then this is here I enter the value of my function, and I'm gonna go to the corner where my little plus is gonna be changing on this tiny plus, and then I have calculated what is really the value of the function at each x. Now I need to find the area for every little triangle, and then for the first one is going to be equal b5 minus b1 b4. All right, and okay, I will have this as because I want to find the length times the width, times then is going to be c5. Okay, and then here I will do for all the triangles. Now what I need to do is I need to find the sum of all these areas. Then here I will say again I need to find the sum function and insert that sum function, and here I'm done. This is the area under the curve for that one, which is the integration of this function. Then I'm done from the first function, done. Okay, and there is a question number 7 in the handout. Answer this question in a textbook on the integration sheet. On the sheet, you're gonna enter, you're gonna insert a text, box, and you're going to have it and write in it what is really the answer for the question. Okay, the second one, it is the root search. We're gonna go to the root search. For the root search, we have two functions, one on the right and one on the left. Okay, and then what I will do is I will find what is really the left hand side, what is the right hand side, and then when the difference between the two is going to be my 0. Now we are going to do this gradually. Then I will say this is 0. I will first enter 0 1 till 20. Okay, this is the first thing I'm gonna do, and then I will make these finer and finer. Okay, and then here I will here make I will like to add here a difference column which is the difference between the x and the y, between the left and the right. Now here on my left I will enter x, which is the 0, times exponential again, exp here, exponential of x. This is my left hand side, and then all right, okay. Oh no, okay, I did a mistake here. Let me erase this. Okay, that's it for this one. And then here I'm gonna enter normal values for this. And then for the right, equal 5 times exp again, and that x again, which is my x here, and then minus 5. The order of operation is going to take care of it. So, you know, like you don't have to put parentheses here. And then here, what I will do, as I told you, like I know this is the left-hand side, this is the right-hand side. When the difference between them is going to be 0, this is my root. Then I'm going to say this minus this. Okay, and I'm going to scroll down and see. Now, if you look here, you are going to find my numbers. Negative, 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 and then it did change from negative to positive. Then for sure here, I'm gonna have my root when that difference is gonna change from negative to positive. And therefore, I'm gonna come here, okay, I'm gonna add, and I will add, insert, I will add kind of 4.1 first, okay, and then I will add also insert. I'm gonna insert more. Okay, I'm gonna insert more more columns. Okay, let me insert here. Insert more so that you will get, I want to get all the functions that I like, the numbers that I need. Then here I will say 4.3, 4.4, 4.5, 4.6, okay, 4.7. Let me see if like, okay, and then here I will get this. I will get this here. And then I will get this. Oh, I put it the wrong way, seems. Yeah, and then now here, look, I have it between 4.1 and 4.2. Then I'm gonna make more. Okay, why did it, like, I don't need to do that anyway. Like, okay, then here I need to know that it's my root is between 4.1 and 4.2, and then I'm gonna make finer and finer, okay, till again I will be able to determine. This is, let's say, now I'm gonna say 4.11, 4.12, okay, I'm still in the negative, 4.13, okay, 4.14, I'm still, then here you add more, insert, I'm gonna insert more, insert, all right, and then here 4.15, 4.16, 4.17, 4.18, 4.19. Okay, and then if you look here, okay, it is between 4.19 and 4.2. Then what I will do is, now again I'm gonna insert more. Okay, and now I'm gonna make it like finer and finer. You will keep doing this. Okay, then here I will say, let me add more. Okay, now I will say 4.191, and then 4.192, and 4.193, and you're gonna continue till you are able to get you will find that refill column A, starting with lower limit and choosing a step increment much smaller than the first, and making sure that the upper limit is reached. This tedious task can be simplified by clever addressing. Repeat this procedure until you have tiny increments to get the solution to 12 decimal places. And then, okay, then you are going to repeat that. Okay, just my other root search. Okay, you're gonna find that you will continue doing till you will get your root. Okay, now one thing that I want you to know also is what I was doing with my other Excel. Okay, also we need to graph. You need to graph the difference versus the difference between the left and right function, so that you will also get this. It will show you also where your I would say root is. I have the graph. Let me see why it's not showing up. Yeah, like I will say insert. I don't know why I lost it. My X. I don't want to show all. Then just I want to get maybe to get something around from 36 to 65. $36 to 65 maybe. Yeah, here is my graph. Okay, it's here. Okay, then this is the graph that is showing me also where my root is, like okay. All right. The last one, it's about noise. Okay, about getting rid of the noise. Let me go to the initial file that you're gonna get from I don't know why I lost. Where is my other file? It's here. Okay. This is here, the one for the noise. You will find that there is something like this one is a function that is gonna be what distorted. It's not clean. Okay, then if I will insert, okay, look here, it is actually, it is not clean. It's not a function that it should be. Now we are going to, first we made this graph. Now we are going to insert here another column, and I will use just I will say here I will make this the noise, and then here I will say I will start with an amplitude, any number that is I'm gonna call it A. Okay, then here I will have them. Okay, I'm gonna list these here. I will say this is my A equals, oh sorry, my A, capital A, my A is, let's say, 5. And here I will say also this is my A, my amplitude, and X is gonna be the harmonic number. I'm gonna make it, let's say, 3. Okay, and then here what I will say, I'm gonna create a noise function which is going to be this amplitude. Okay, and in order to, you know, I can change it and is gonna stay in my function, I'm gonna put these $signs here, times, and then sign, and also I'm gonna do the same for this one. Okay, and then here I will have, you know, calculate the number for all. Now I will add another column. I will say corrected signal. Then I will subtract the value of the function minus the noise, and I'm gonna get this number, these numbers. Now I want to graph now the signal without the noise. Then what I will say, insert, and here, okay, I'm not yet done. I will select data. Okay, then here for my X, I want to get all my X's here. And for the Y, I'm gonna get the correct signal, which is the F column. It's correct, I believe. Okay, then this is here. This is my new function, and it's not that much better. Okay, let's see here. I'm gonna change this into 2. I will see it's gonna reflect on it. If I will change this into 10, like I'm just playing now, just to show you how this is gonna affect it. Let's say this is -1, and how this is. Now, the first thing you are going to start with is gonna be by trial and error. And then after that, you will start being able to see what is really the trend, where you should go with your numbers, so that you will get this is a clean one. A clean one means this is my one. Okay, this is the clean one. Okay, then here you are going to graph it and find you should have the two graphs, the one before and the one after. And this is really what is needed for today's lab, for this lab. Okay, an Excel sheet only having all these three parts. Remember, in order to get the full credit of this lab, also you should watch the full length of the video. Thank you.